Okay, chapter 3 is about combinational logic design. We will design now a circuit, a fully complete circuit. So we will start with the specifications, okay? And then we will convert it to a truth table. Then we will, with the help of K-maps, we will find the Boolean expressions, and then we will draw the circuit. So in chapter 3, we will go over combinational circuits. Okay, so what we learned in chapter 2, we will apply now in chapter 3. We start with what is a combinational circuit. Combinational consists of gates. So here you see AND, OR, NOT, XOR, XNOR. So all the logic circuits or gates, that we learn, you will use them in the combination circuit. You will have many inputs, let's say M Boolean inputs, and of course we can have N Boolean outputs. So N switching functions, each mapping to 2 to the power M input combinations. Let's say here you have 4 variables. You are going to have 2 to the power 4 combinations in the truth table. So you will have 16 cases, okay? If you have 3 variables, you are going to have 2 to the power 3 as input. So you will have 8 cases. So this is how you create the truth table of 4 variables, 3 variables, 5 variables. How do you do that? You do 2 to the power the number of input, so you get the number of combinations available in the truth table. What is the design procedure? The first thing you need to know is the specification. You write a specification for the circuit if one is not already available. So you will have to read. It's an English paragraph that actually explains what do you want to do with the function, okay, or with the circuit. What is the output? Formulation, you derive a truth table. So now that you know how many input variables do you have, how many output variables are you going to have, you create the truth table. Then we move to optimization. Optimization could be done in 2 ways, either using Boolean algebra or using K-maps, okay? What happens when you do optimization, you are actually creating a multi-level optimization. So you move, let's say, from 3 level to 2 level to make it optimized with less number of gates, less number of literals, less number of gate input. You draw a logic diagram or provide a netlist for it with AND, OR, and inverters. What is technology mapping? This is where you actually map the logic diagram to implementation technology. And in the last part, you verify the correctness of the final design. You could do it manually or you could do it with simulation. We will learn how to do both. We will learn how to do it manually on a paper, and we will learn how to do it simulation, how to do it electronically via a program that is called LogiSim. So we will do a project on LogiSim where we are allowed to do simulation. Okay, so you give input for the paragraph, and then you check the simulation. I mean by that, what is the input that you have? What is the output that you are going to have in the logic circuit? You check for many inputs. So let's say you check for 0, 0, 1, 1. You check for 1, 0, 0, 0. You check it for 1, 1, 0, 0. And you see if the output is that you are getting out of the logic circuit is correct. So this is what we will be doing in chapter 3. I will start with one example, and this is an example that you can get similarly in an exam, or you can also get in a logic simulator when you are doing it on LogiSim. Okay, so follow the example and try to understand all the steps that we will be doing. What was step 1? It was specification. The specification here, we are trying to find or to create a converter that converts binary coded decimal to excess3. I need your help now, please. How many, to specify the variables, I need the input and the output. How many variables do I have for the input, please? Can anyone try? How many?
4.
4. How did you know 4?
لأنه كل digit بالبيس 10 بياخد value من ال 0 لل 9 بدنا القليلة
In
10.
binary coded decimal, you mean, right? Not in decimal, right? In binary
Yes.
coded decimal, you need 4 digits to write, let's say, number 9. So it's going to be 1, 0, 0, 1. So this needs 4 variables. Okay? And then how about the output? How many variables do you need for the output? What do you think?
1.
Only one? If you have number 0, 0, 0, 0 and you want to add excess 3, what we are doing here, we are adding 3 to the input. So we have, for my input is 0, my output will be 3. How would you write? How many bits do you need to write? 0, 0, 0, 0 plus 3. What do you think?
0 0
Also 4.
بتصير 0 0 1 1 يعني
Exactly.
0 0 0 plus
I also
1.
need 4 digits. So I have 4 inputs and I have 4 outputs. You got the idea? So from the specification, you will have to find out how many bits is the input and how many bits are the output. So here, we do the formulation. We check that we have A, B, C, D as input and W, X, Y, Z as the output. Of course, you can give them any names you want. But in the BCD, I have don't cares. Who can explain to me what are don't cares in BCD?
values greater than 9.
Perfect. What are they? So 10 till 15, we don't have a value for in BCD. This is why we refer to them as don't cares. Okay, so my input from from 10 till 15 are don't cares. We have values for, we don't have values for, okay? Check the truth table, please, and try to tell me what's going on from here to here. Yes, please. Can you try to? So this is
Yes.
0, 0, 0. What happens here? What's the output?
We add 3. بصير 3.
Yes, very good. What happened here to number 5? It became
we add 3
8.
8
How about the 9?
9 بتصير don't care بتبقى
No,
مثل ما
no,
هي.
no, no. 9, I still have a value for it. It is 1001. 10 is a don't care. Okay?
ايه بس اذا 9 زدنا لها 3 بتصير
Very good remark. Very good remark. This is not in BCD. This is only in BCD. You got the idea? This is not in BCD.
Okay.
So here you can write 10, 11, 12, no problem. But here you stop at 9. Okay? So this is in BCD. This is not in BCD. Clear? Is the truth table clear? How about here in the rest of the truth table? I have 10, 11 till 15. What do I write here, please? I write don't cares. So they are all don't care. And of course, the output will also be a don't care. Clear? Now we need to derive the K-maps. How many K-maps do you think I have for the output? How many?
بس دكتور آخر شيء بالتيبل
Yes.
ليش ال9 صارت 1011 مش 1100
9 is, this is wrong. You are right. 9 should be 12. It is 1100. Yes, you are right. Let me scratch
okay.
this for you so you pay attention while you are studying. It is 1100. Yes, you are right. 9 should be 12. It's a typing mistake from the book. Okay? Yes, I was asking, please. What should you have after the 9 here in BCD? What did we say? What do we have here? We have don't cares. You agree?
Care.
Okay. My question was to you, how many K-maps do I need to create? Each output will need a K-map. So I have a K-map for W, a K-map for X, a K-map for Y, and a K-map for Z. So I have 4 variable K-maps. Okay, so I need to create 4. One for the W, one for X, one for Y, and one for Z. You got the idea? and we fill in the K-maps. How do I solve it? I take 4, 4. This will give me 8. Okay, so this is actually D bar. So this is Z. We move here and we fill the K-maps. I have a question for you. Can you take these 4 with these 4 in one term? What do you think?
لا
No. I need
لأنه
to
مش على
take, they are not adjacent. So I need to take this 4 alone and this 4 alone. I want someone to tell me, what do you notice about this Y? It is CD plus C bar D bar. What do you notice about it? We studied that in chapter 2.
One.
No. This is, which function is this, please? This is, if you
X
know,
نور X نور
very good, very good, perfect. So it is C. Okay, it is X NOR, remember? And this is not equal to 1,
Yes.
be careful. This is C XOR D with a bar, it will give you C X NOR D. Okay, so be careful to that. And how about B bar, this, we are working on this. What happened, please? What are the terms that we can take? Who can help? Here, this 2 is a term. Then what, please? You have these 2 with these 2. And these 2 with these 2, they will give you another 4. Okay? We move to the W. You can take 8, then 4, then another 4. Okay? Now what? I did. Yes.
الزاد وين position تبعه؟
Z, this
يعني
is the Z. You want to look
Yes.
on the truth table, you mean?
Yes.
Okay, let me go back to the truth table. Notice, please, it is 1 0 1 0 1 0 1 0. Did you see it? And this is it. This is the Z. No, not this one. So if you notice,
Yes.
please look at Z. It is the complement of D. Did you notice?
Yes.
So you didn't need to draw a K-map. You could directly say that Z is equal to D bar. And if you still want to draw a K-map, you will still get the same answer. It is C equals D bar. Okay?
Merci.
Now what happened? I created 4 K-maps, and each K-map gave me a Boolean expression. You agree? Now I am ready to draw the Boolean expression. Now I have a question. What is this to you? Here, what can you do to summarize or to optimize this? Can you do anything?
Yes.
What can
B
you do?
bar plus B bar factor B bar sorry.
You can take B bar common
C
factor
plus
into C
D.
plus D, yes. Okay.
Yes.
and you have-
We will B bar
Hmm.
factor CD.
Yes, you can do that, okay? So let's check now, please, the literals. I need your help. If you are counting the literals that you are seeing, you will have here, notice please, with the multi-level that you are using, I have W equal A plus BC plus BD, okay? So these are the equations. Let's count the number of gate input that you have. Yes. Who can help, please, here? We start with the L. What is the literal? Number of literals, please. Sorry, I didn't hear you.
5.
5
Yes, 5. You are right. What about X?
7
7.
Yes. And Y? 4.
4
And
4.
Z? 1. Now let's move to G. I want someone to tell me what is the G for W.
7
How did you decide it's 7? You have
7
1, 2, another 2, and these 3 are input to the OR. You agree? This will
yes
give you a 7. Okay. So as a result, the G is going to be 7 plus 10 plus 6 plus 0. It's going to be equals to 23. Okay. So here they are trying to find a way to transform it just to make it easier, okay, to optimize. So they took here C plus D common factor. So you have B common factor, sorry, it will give you B into C plus D. And here also you can take B bar common factor, it will give you C plus D. You notice? Okay, so also when you are working on the Y, you cannot take it, and D on Z, you also cannot take it. So you have W and X. This is simply to try to do a bit of extraction, so it makes it less gates when you are counting. See, it's 19, it was 23.
دكتور شو قصة
Yes.
الزيرو؟ أنا ما فهمت قصة الزيرو اللي أخدنا دي
Do
بار
you
equal
have
لزيرو.
any gate input here? You don't actually have a gate.
Gate input.
You don't have
No,
or.
just D bar. Okay.
You don't have a gate.
Okay, gotcha.
You only
Okay.
have an inverter. Okay, so this is why you have
Okay.
it zero.
Thank you.
دكتور
Yes.
فيك بليز تعيد للجي تبع الاكس ما فهمت كثير كيف جبناها.
Yes. You count 1, 2. That's the input for the AND. 1, 2. That's an
Okay.
input for the AND. 1, 2, 3. It's the input of the AND. Now you will have 1, 2, 3. The input of your OR. So 7 plus 3 will give you 10.
اوكي
Clear, or you want me to draw it?
لا مش الحال.
Okay. Okay, let me see if you understood. What's the gate input of this?
اوكي بس عندك 1 و 2 between the
This is 2 for the AND,
صح وهونيك 2
for the AND.
and then
For the OR
في
now you have 2. So this makes it 6, okay?
yes.
You can continue with the optimization if you want, okay? So here you have G equal 19. This is the second level. Now they are saying here that CD bar, you can say that it is T1 bar. You already have CD to be C plus D when you bar it, so you can also replace it, okay? So this is also referred to as Boolean transformation. What happened here? It became 16 your G. So again, this makes it less number of gates and more optimization occurred. Did you understand what happened here? We replaced C plus CD into by T bar, okay? So here we had C plus D, it was T1. Bar it, what will happen? It will become C bar dot D bar, you agree? So I have T1 and I have T1 bar. And this will help me to do another Boolean transformation, okay? Any question about this before I start something new? It's called mapping. Okay? Okay, we start. Do you remember what I said in chapter 2 about AND and NAND? Yes, please. How do you draw an AND? This is an AND, you agree? How do you make it an AND? You put a bubble, right? How about if you have, so this is A, B, bar it, it will give you A bar plus B bar. Do you remember that an AND could also be represented with an OR, but it has a bubbled input, inverted input?
دكتور are you writing شيء لأنه مش عم يبين شيء عندك.
ولا
Yes,
أنا.
me too.
ايه ولا انا.
How come? You
اوكي
can
هلا
see?
مبين.
بينت هلا
Yes.
يس هلا بين.
So this is how you do
انا
the
مش
thing.
مبين شيء.
It's internet. You wait a bit, okay? So this is A, this is B, and this is A, NAND B. And here it is A and B, but they are complemented. So you will go with A bar, B bar, and this is an OR gate. And here you will also, as a result, have an AND. You got the idea? So this is an AND, and this is, sorry, this is an AND, and this is also an AND. Do you agree? But this is an AND with an AND gate. This is an AND with an OR gate. Jad, is it clear?
Yes doctor, thank you.
Okay. We will move now to the OR. So I will now move to the OR. I need your help now with the OR. So this is the OR. How do you make it an OR?
اللي وراها
I add شو
A bubble, right?
اسمه
A
bubble.
plus B bar will be an OR. You agree? So use the Morgan's law. It's going to be A bar dot B bar. What gate is this?
and
So this is an AND, but you bubble the input, and this is also an OR. Okay? Clear? I want to do mapping now. I want to make sure you understood this because I need them in my mapping. Are they clear? So NOR could be represented with an OR and a bubble, and it also could be represented with inverted input and gate. Yes, are they clear? Okay, so we start.
Yes.
I want now to do the inversion or the mapping from this figure to use only an AND gate. Okay, so only NAND. I don't want to see an OR gate, only NAND gates. I need your help. I will start with the easy one. Here, this AND gate. How can you change it to an AND?
Put a bubble.
Place a bubble in front of it.
You put
Sorry.
a bubble, okay. When you put a bubble, are you allowed to put one bar? Putting a bubble is like putting a bar, you agree? Are we ever allowed to put one bar?
No.
What should we put
I have to
always?
change the
Two bars.
next to it or before
We
it.
always put 2 bars. You agree? Let me write it down to double check that you remember. You put x bar bar, it is equal to x. Okay? Clear? 2 bars will be equal to x. 1
Yes.
bar will not be equal to x. Okay, so I will try now. It's a bit difficult to draw, but I'll try. You will put here a bubble. Okay, but can I add one bubble only? No, I have to add another bubble. You got the idea? Did you understand what I
Yes.
did? Okay, how about this now? Or in other words, let me show it to you in other words. You can put a bubble here and an inverter. So now these will be equal. Okay, how about here? It's also a bubble with an inverter. Bubble and inverter. Why am I putting the inverter? Because x bar bar is equal to x. Now this is a bubble and inverter, bubble and inverter. Okay, now how do I convert an OR to an AND? Yes, your help please.
2 bubbles before the
2
OR.
bubbles before. So I put it's not drawing properly, but you got the idea, right? I'm putting a bubble before, okay? And here I also put 2 bubbles before, and here 2 bubbles before. How about here? 2 bubbles before. Is the idea clear? Now what is going on,
Yes.
please? I have 2 bubbles, okay? So what can you do? This one should be changed to a NAND. This is a NAND, okay? And this is a NAND also. When you put a bubble before the OR, is that it, or you need to add an inverter also? You got my question? When you add
I
a
think
bubble,
yes.
you need to add also inverters, you agree? So this
Yes.
will have an inverter, this will have an inverter, and this will have an inverter, and also here. Okay? Now what? You need to know if you have inverter 1 and behind it inverter 2, you could cancel them and they will be with no inverters. How about if you have 3 inverters, how many are you left with?
1.
on
So these will go and you are left with 1. You got the idea? What do you do
Yes.
now? You check how many inverters do you have and you eliminate those that are, what do we call them, adjacent. So you have here an inverter, here, here. So you could eliminate these two. You got the idea? Here two you could eliminate. Two you could eliminate. Two. See? So this is how you could eliminate them. And I'll show you what is the result of it. So this is going to be the result of what we did now. Okay? Any question?
Yes دكتور.
Yes.
لما بالانبوت بالسكندري لاين تبعه يعني مش بالمين لاين لما يطلع لما يصير في كذا لاينز لإله يفوت على كذا جيتس مش
Yes.
بس وحده ايه هيدي يعني بنكون عملنا فاكتورينج
Yes, I'll show you.
هيك صار.
Yes, yes, I'll show you. Give me a second. See, this is what you are asking. Let's say you have a knot here and you divided it into three. You will have as if 3 knots. Is this what you're asking about?
ايه kind of
Okay, so yes, it will be. If you
كان قصدي انه بالبوليون اكسبريشن كيف تطلع.
لا, you don't work on the boolean of it until you finish the conversion. Okay? And with a not, with a and or not, it will give you the same input as with only NAND. It's going to be the same output, so not a different expression. They will be the same output, okay? So you need to do in exam 2, of course, not exam 1. You need to know how to map, given any circuit, so given any circuit, I will ask you map it to an AND only or map it using an OR only. You have to do this, okay? Any question?
Yes.
Let's say now you need to control the complexity of a function. And when drawing a function, you have to be careful that the blocks, small pieces called blocks, they create a bigger block. So let me show you, please. This is what I mean. I will start with this. This is a big block. You have 9 input. You have inside a 9 input odd function, and you get as an output Z. Okay. This 9 input is a big block. What do I have inside this big block? I have 3 input odd function, 3 input, 3 input. I get output out of it. They are also input to a 3 input. If you only look at these 9, let me try. These 9 and this, you see the similarity? Okay? How about now? I want to look what is in this only. So I have here 3 input and 1 output. The input of a 3, you have actually 2 XOR in it. 2 XOR, because I have to refresh your memory that XOR does not take 3 input. So you cannot put 3 input on XOR. What are you going to do? You do 2, you XOR them, and their answer, you XOR it with another. See, this is the idea behind 3 input odd function. This is not allowed. This is allowed. Okay? So this is why a 3 input odd function, a 3 input odd function is going to be this block that you are talking about. How about 1 XOR? Do you remember how do you create a XOR? It is XY bar plus X bar Y, right? So I actually have 2 and an OR with 2 complements, okay? So what are we saying here? I am saying that you can create a 1 block, and then the inside of the block consists of many blocks, and each block also consists of lower gates until you reach and or not. This is the lowest level of gates that you could use to create blocks. They are the and or not. Okay, so when you buy a chip, let's say a CPU or a RAM, you only see a block which is made up of 2 by 2 chip. Is this the content of it? No. Deep down at the lower level, you will see and or gates. Okay? So what is a top-down design? This is when you start from the top and then you go downward until you reach the lowest level of details. How about bottom-up? Bottom up, you start from the lower level of detailed primitive blocks, and then you combine them until you reach the more complex functional blocks. So it is up to you. This is up to you. How do you want to design? You can design bottom up or top down. How do you map to NAND and NOR gates? I just explained it to you, but very quickly, when you are, I will repeat the idea that you can convert an AND to an AND and an OR to an OR by adding a bubble after. Okay? So I repeat the idea. This is when you have an AND, you add a bubble after, but you cannot add a bubble by itself. You will have to add a NOT behind it. So bar will be eliminated. How about if you are converting the OR? You will put bubbles before it, but every bubble needs an inverter. So you will have inverters, and this OR with inverted input will be converted to an AND. If you did not see it clearly, let me draw it. So this is the OR, and you have bubbled input. This will be converted to an AND. Is the idea clear? Okay. When you have two adjacent, you could eliminate. And this is the case where it is going to be factorized, and you can have, it goes in many paths. So here you could add NOT to every path. The same goes for the NOR. So you will have the mapping is accomplished in the OR by adding a bubble after it, and this will give you the NOR. So check this place. This is an AND. Put a bubble before it. It's the same as an OR. Is the idea clear? Okay. So this is how you actually change from an AND to an OR. Also, if you have an OR, put a bubble after it, it will be a NOT. But don't forget that you also have to add an inverter. We don't usually add a bubble only. Every bubble needs an inverter after it. Okay? So this is how you map from an OR to an OR. So you put before the AND two bubbles, and every bubble needs an inverter. So this is why you have two inverters here. Did you get the idea? Any question?
Yes.
Yes, please.
الجزور بنستعملهم شي كبيزك جيتس.
No,
الجزور
they are not
بنستعملهم.
basic. They are not primitive. These are complex gates. Okay?
يعني نعملهم من ورا ال and والنوت.
To create a XOR gate, you need AND or NOT gates. So it is not a primitive gate, the XOR. It is a complex gate. Okay?
Okay.
Any question? How about when you want to do verification? Verification could be done in three ways. You could do it in truth tables. So you verify the output that you are seeing, input that you are seeing, what is its output. You could do verification via check place, manual or simulation. I'll do an example. This is a truth table. You have the input and the output. How do you manually verify? You check, let's say, for each of the following values, what is the output that it's going to give? So let's say for number 4, it's going to give you 7. So you go over it one by one, okay, one by one, and you check the input. Is it equal to the output that you are getting? We call this manual simulation. So one by one. However, in the LogiSim, you will have to do, I'll show you. When we finish chapter 3, I'll show you how to do simulation on LogiSim. All of you need to download, okay? It's a small software, it is for free. I want you to download on your laptop, okay? So make sure, download it, and after we finish chapter 3, we will do simulation on a circuit. What do I mean by simulation? I give different input for my circuit, I click, it will give me the output. I check, does the output match my truth table? Then the simulation is correct, okay? So this is how you compare simulation manually or via software that you can use. So here you can check one by one, are you getting the correct output? Okay, so the tables match, then it is verified.